Today is the second day discussing error, specifically LaGrange. And what we're going to be doing in this specific lesson is to determine when to use the two different kinds of error tests, whether we're going to use alternating series or whether we're going to use LaGrange. So this is a review of the alternating series remainder or the error function. Up here at the top, it tells how to know whether to use alternating. What you have to look for is if your series has terms that are alternating, that kind of makes sense, decreasing in magnitude, in other words, they're getting smaller, and having a limit of 0. Then you will use, anytime it asks about error, you will use the alternating series error term, which means it's going to be less than the absolute value of the first omitted term, a sub n plus 1. So if it tells you to go out 4 terms, you use the 5th term. If it tells you to go out 3 terms, you use the 4th term. We've done this before. We're just reviewing it. And we're talking about it compared to LaGrange, how they look alike, and how to know when to use which one. So at the bottom, it has it a little more simplistically. In other words, if the 3 conditions up here are met, you can approximate the sum of the series by using the nth partial sum. In other words, you add up the terms up to where you stop. And your error will be bounded by the absolute value of the first term you chop off, a sub n plus 1. So we're going to do an example where we use this. So I know that some of you are stressing about this test on Wednesday. Yes? Okay. I want to show you that you know more probably than you think you do. Okay? And you can be getting points for things that you've been using all along, specifically with the next question. I'll show you how this works. The Taylor series about x equals 2. What is the significance of that? The about x equals 2? That's your center point. That's where the two graphs touch each other. And what letter is it really? It's really not x, it is C. Very good. This is C. For a certain function, f converges. Oh, it converges, so that's good. To f of x for all x in its interval. So we know it's going to converge. We're going to check and see if it alternates. The nth derivative of f at x equals 2 is given by this function here, and f of 2 equals a third. Now, I'll tell you right now, when I first read that, I kind of went, what? What do you do with that? Well, don't worry about what you do with it just yet. Let's just start working the problem. Part A, write the second degree Taylor polynomial for f about x equals 2. We've been writing Taylor polynomials all along. Yes? Yes. So let's write the formula first. P little 2 of x. P sub 2 of x. Why 2? Why did I put a 2?
Because they want the second degree.
Second degree. Okay. Now, all polynomials start with a fraction. Now I want just the formula. What it goes on top of the first fraction? Do you remember? F of 0, f of 5, what f of what? F of 2, good. The bottom is a factorial. What factorial comes first? 0, good. And then what goes out here? X minus 2, and what's its power? 0, because the factorial is 0. So now that I kind of got the ball rolling, do you remember how this works? A little bit? What goes on top of the next fraction? F prime of 2, very good. Over 1 factorial, x minus 2 to the first. Plus, what goes next? F double prime of 2 over 2 factorial, x minus 2 squared. Do I keep going? No, I'm done. Why do I know I'm done? It says second degree. Second degree means stop when you got a squared. Okay, now let's plug in stuff. They will have given us everything we need to do this problem. Yes, ma'am?
Do we only put the plus down for the series?
If it says a series. That's a great question. If it says polynomial, you stop. If it says series, then you got to put plus dot dot dot. I'm glad you asked that question. Series go on forever. Polynomials stop. Okay? So now let's start plugging stuff in. P2 of x equals, do I know what f of 2 is? What do they tell me? 1/3. So 1/3 over, what is 0 factorial? 1 x minus 2 to the 0. Now, if you want to start cleaning up, you could start cleaning up. I'm going to go ahead and write it all out for those who need to see it. All right? Now, do I know what f prime of 2 is right now? No. Can I find it? Yes. That's where this funny little equation comes into play. Okay? The question is, what do I plug in for n? 1, because it says the nth derivative. So if I want the first derivative, I plug in a 1. Does that make sense? So I come out to the side. f1 of 2. That's another way to write first derivative. Do you have a question?
X minus 2, what power is that?
That's a 0. Let me fix that. Okay, now start plugging in 1s for everything else. -1 to the n. 3, oops, not n. I just told you to plug in, and I didn't do it myself. -1 to the first, 3 to the first. Clean it up. What do you get? -1/3. So that's my f prime. That goes on top of the fraction. What is 1 factorial again? 1 x minus 2 to the first plus f double prime. Do I know it? No. Can I find it? Yes. Using the same formula. Plugging in what for n? 2. f2, 2 equals -1 squared, 3 squared. What's that going to be? 1/9. So 1/9 over, what's 2 factorial? 2 x minus 2 squared. All right, now we want to clean it even more. So we wrote the formula, we plugged in everything, now it's time to clean it up. First term, 1/3, that's it. Plus -1/3 x minus 2, do not distribute. Plus, what's 1/9 divided by 2? 1/18 x minus 2 squared. That is done. You just earned points on the test right there. And a lot of the problems have you do that first thing. Build the Taylor polynomial. Okay? Does everybody understand why we stop at 2 at double prime? Do you understand how the pattern goes to plug in stuff? F of C, F prime of C, F double prime of C, those are the tops. Now, if they'd have given us a function instead of just saying f of 2 is this or whatever, then you would take the derivative yourself. Okay? So, it says, now on part B, show that the second degree Taylor polynomial for f, in other words, what I just made, about x equals 2, approximates f of 3 with an error less than 0.01. Okay. When the word error pops into the problem, you have two options. Alternating series error, LaGrange error. LaGrange is more difficult to do, so we'd prefer to do alternating if possible. So what you got to do is check your problem. Is that problem alternating?
Yes.
Is it going from positive to negative to positive? Yes. And the next term, if I went out to the third power, it would be negative. So it is an alternating series. And those fractions are getting smaller. Okay, I know the 1/3 are the same, but once you plug in a number for x, that one will be smaller. It's going to be getting smaller. So we're good. This is going to work with alternating series. So we need to write that down. Since P2 of x alternates, decreases, and the limit equals 0, the next term will be the error. Okay? The next term will be the error. Since the P2 of x alternates, decreases, and the limit equals 0, the next term will be the error term. Yes, ma'am?
Why do they just decrease it?
Okay. If you look at these fractions over here that make up this right here, as I keep putting powers on, the top's just going to keep going back and forth, positive, negative, positive, negative. The bottom is just going to keep getting bigger and bigger and bigger. And if the bottom gets bigger, the fraction gets smaller. Okay? Yes?
So if it was decreasing, wouldn't it always have the limit of 0?
Not always. It could decrease down to like 2. Start higher than that and decrease to 2, but it has to. Usually it does, but sometimes it doesn't. You got to check. All right. So you can use, again, the same terminology that we used for LaGrange for the alternating series. So R2 of x, the absolute value, is going to be less than the next term in the sequence, or in the series, excuse me. So here is the last term that I just made right here. Or actually, let's look up here at the formula. What would be the next term if I kept going? What would it be on top? F triple prime of 2 over which factorial? 3. And then x minus 2 to the third. That's the next term. So if it alternates, that's how we find the error. Just go to the next term. Complete the formula one more step. Okay? So, let's see what we got here. This is going to be less than triple prime. Okay, so let's go back up here and do the triple prime. F3 of 2 equals negative 1 to the third, 3 to the third. I'm off the page there. What's that going to be? Negative 1 over 27. Good. So absolute value, negative 1 over 27 over 6. Now stop a minute. We know what x is. X is whatever they plugged in the function, 3. So 3 minus 2 to the third, close your bracket. When you build that error, you should have every number taken care of. Because errors are numbers. How far off are you? I'm not off by x plus 2, I'm off by 6. You know, it's got to be a number. Okay, now we go to the calculator. But what is 3 minus 2 to the third? That's just 1. 1 to the third is 1. So mark that out. All you got to do is put that in the calculator. Now remember that the negative, we don't even need to worry about it. So 1 over 27, and then divided by 6. And I get 0.00617. So 0.00617. Is that less than 0.01? Yes. Check, I'm done. Are you following what I did?
And we're allowed to keep it as a fraction.
I'm allowed to do what?
Are we allowed to keep it as a fraction?
Yes. You can leave it as a fraction. Any questions? Yes.
So when you did R subscript 2 x, what does that represent?
What does that represent? Good question. That represents the error. How far off my estimate is from the actual answer.
Okay, so
Now, I haven't found, in this case, f of 3. Now, if I plug 3 into here, that would be my estimate for f of 3. This is telling me that my answer that I get with plugging in 3 is off by about that much.
and we're always going to compare it to 0.01?
No, we will compare it to whatever they tell us. Sometimes they'll tell us 2/3, sometimes they'll tell us 0.5, but because it says less than 0.01. All right? Did you follow what I did? Not too bad. Okay. Let's move on to the next one. This one says, let f be a function that has derivatives of all orders. In other words, you can take the derivative over and over again. Assume all of this stuff right here, blah, 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 and the graph of the fourth derivative is shown at the right. When I saw this problem the first time I did it, I said, I've never seen anything like this before. And that kind of scared me. But you know what? I said, okay, I'm not going to worry about it. I'm just going to move on. And hopefully how I need it's going to show itself. The graph of y equals the fourth derivative is increasing on 2 to 3. I guess that's important for something. I'm not sure yet what it is. Part A, find the third degree Taylor polynomial p of x about x equals 2 for the function. Now, did we just do that? But a second degree? Yes. All right. You have 2 minutes to work with your table. I want you to build it right now. You should know how to do this by now. So take a few minutes, build it. Look at your answer, see if it matches mine. Check your signs, check your terms. Now, if you reduce the last fraction, it does reduce to 1 over 14. Okay, that will get you full credit right there for that part of the question right there.
But after the whole thing, we put the 4
Over 0.
I got it right.
How do you get
It's negative, it's 3 over 7 over 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So 3 sevenths divided by 6, 3 over 42. You're welcome. Anybody else have a question? Are we good? Awesome. Okay. Now, so were you able to do that by yourself? Yes. Look at part B. Use your answer to part A to estimate the value of f of 2.8. What does that mean I'm supposed to do? Plug in 2.8. Can you do that by yourself? Go for it. Show me what you can do. Plug 2.8 in for x. And clean it up before you plug it in the calculator. It's a lot easier. The question said, what is f of 2.8? If all you write is that, you haven't answered the question. You need to write down that f of 2.8 is approximately equal to p of 3 of 2.8. You've got to write that part down. And you may not have thought of that. I'm just telling you now so that you understand that. Because the question says, what's f of 2.8? Yes?
So if we did that on the quiz, you don't get that point or no?
Quiz, I don't care. I mean, I didn't tell you, so you're okay. Yes?
So you only need to write what's in the box. You don't have to write like the entire thing.
Correct. That's what I was about to say. So, do you have to write out all the math? No. As long as what's in the 2 boxes is there, you're good. That's what will give you credit. Okay? If you like to write out all your steps, write out all your steps. The only time you really have to write your steps out is when it says to show your computations. And this one didn't say that. Okay? Any more questions on part B? Okay, so far so good.
Yeah.
2/3 done, all by yourself. Okay, part C. Let's move it up. Okay. Use information from the graph of the fourth derivative. Okay, I guess I need that graph now. To show that the absolute value of f of 2.8 minus p of 2.8 is less than 1/8. Okay? This right here is code that we talked about last class. And what does that represent right there? Error. The difference between the actual value and your estimate. F is the actual, P of 2.8 is the estimate. And in any sort of situation, when you take the actual answer and subtract the estimate, you get the error. That's just what it is. Okay. So, error, they didn't come right out and say error, they just kind of implied it. Now the question is, which error formula do I use Do I use alternating or do I have to use LaGrange? I have to use LaGrange because this one is not alternating. All right, so we're going to use LaGrange. Let's review how that works. It looks very similar to the alternating. The Lagrange says R, this is R3 of X this time, is less than or equal to, yes ma'am?
Why is it not alternating?
Because it goes plus, minus, minus, plus. It has to go plus, minus, plus, minus. I got two negatives back to back.
Then I see it.
Okay. So now, when we build Lagrange, it's still absolute value, but the new part is the M, the magic M, the magic max. The rest of it is built just like we built alternating. Which factorial comes next? After where I stopped. I stopped at 3, so it's 4 factorial, and then x minus 2 to the 4th. Everything else matches alternating. Everything, except for the M. Okay? Yes?
Is it not 7? No.
Okay, we'll talk about that in a minute. So, they should have told me what M is. What's M? Not M, excuse me. They should have told me what X is. What is X? Careful. Is it 2.8? Yes, it is. You're right. I was thinking it was 3, but we already did that. Sorry. So this is 2.8. We're going to put that in a minute. But now it's time to figure out M. M is equal to the absolute value of the next derivative. What's the next derivative I haven't done yet? 4th of Z. And we put a Z there because it's not X and it's not C. It's the maximum value of the interval.
Yay, 7.
Okay? So it told us to use information from the graph. Well, I guess this is where I need the graph. Also, because it says 4th derivative, and this is the graph of the 4th derivative, that's probably what I need. All right? I am trying to find the error at 2.8. So if this is 2 and this is 3, 2.8 is probably about right here. Okay. Do I know the 4th derivative at 2.8? No. But I know that it is no bigger than what? The y value is no bigger than what? 7. That's my magic max, is 7. So Z isn't 7. M is 7. M is the y value that it can be no bigger than. The fact that it says it's increasing, it tells you for sure that that 7 is the highest y value on the interval. So 7 is my magic max. So now I go back to my problem. I'm going to write in what I just found. So I now know that this is 7 on top. 4 factorial is what? 24. Then put in that 2.8 for the x, minus 2 to the 4th, and that goes in the calculator. Remember that anything for error has to be all numbers. If you haven't found a number, something's wrong. So, you can't see that. I'll just have to scoot it over. Can you see that? Yes, you can. So, don't worry about absolute values, remember, just make it positive. 7 over 24 times 2.8 minus 2 to the 4th. I'm in a weird mode. I need to fix my calculator. Give me a second. I have to retype it all now. 0.119. Now, what are we comparing this to? We're comparing it to 1 over 8. Is that smaller than 1 over 8? I don't know. How would I find out? Plug in the, well, if I put it math enter, I get 224 over 1875. Is that smaller than 1 over 8? I don't know. Okay. It's already in fraction form. So that doesn't really help me. What would help me is to make them both into decimal form. Wouldn't that make a little more, think about it. So let's take the 1 over 8 and make it a decimal. Ooh, that's 0.125. So is that smaller than 1 over 8, which is 0.125? Yes. Check. I'm done. Okay. Now, that may seem kind of redundant. Why do I even, have to check it? It says it's supposed to be smaller. When I was doing the problem for the first time, I forgot my factorial. Not on this part, but the other one. Forgot my factorial. And I went ahead and put in the decimal. I'm like, wait a minute, my answer isn't smaller than what they said. And that's what cued me to go, oh, I forgot my factorial. So I went back, put the factorial in, then I knew I did it right. So that fraction is there to kind of help you make sure you haven't forgot any of the parts of the problem. Does that make sense? Okay. Questions? So now you see the difference between the alternating series and the LaGrange and when to use both. All right? So that's it for today.